Hey everybody, welcome back. If you haven't already done so, please subscribe to my channel. I release new videos every Wednesday morning and Sunday morning. Last lesson we looked at linear functions. Today we're going to be looking at exponential functions, and we're going to be doing some pretty cool stuff using the Python programming language. Let's get started. An exponential function is a function that has the form y equals a to the power x, where a is greater than 0 and a is not 1, x is real. Why is a not 1 allowed? Well, if we had 1 to the power of x, this would just be 1 for any x. And that's, well, mathematically pretty boring. A is the base and x is the power. And it is called an exponential function because the variable is in the power or exponent of the function. This exponential function is used in many fields of study, in finance, biology, mathematics, physics, to name just a few. An important property of exponents that we need to know is a to the minus b is 1 over a to the power of b, or 1 over a to the b. For example, if we have 2 to the power of minus 3, we can rewrite this as 1 over 2 cubed, or 1 over 2 to the power of 3, which is just 1 over 8. Let us look at some examples of exponential functions. Let us consider, for example, when a is greater than 1, and we have y equals 2 to the power of x, and y equals e to the x. E is an irrational number and a mathematical constant, kind of like pi. And e is defined to be 2.71828 and keeps going. Now let us look at some examples when a is less than 1. We have y equals 1/2 to the x, or y equals 2 to the x, and y equals e to the x. Let us graph a table of values. X, y equals 2 to the power of x, and y equals e to the x. Let us consider values for x equals minus 3, minus 2, minus 1, 0, 1, 2, and 3. So when y equals 2 to the power of x, and we put minus 3, that's just 1 over 2 cubed, which is 1 over 8, which on a calculator you can do is 0.125. 2 to the minus 2 is 1 over 2 squared, which is just 1 over 4, which is 0.25. 2 to the minus 1 is just 1 over 2, which is 0.5. And then 2 to the power of 0 is just 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And 2 to the power of 3 is 8. Now let us look at y equals e to the x. E to the minus 3 is 1 over e to the power of 3, which on a calculator is approximately 0.0498, or just rounding it off to 0.05. E to the minus 2 is 1 over e squared, which is 0.135. E to the minus 1 is just 1 over e, which is approximately 0.37. Then e to the 0, anything to the 0 is just 1. E to the 1 is approximately 2.7. E squared is 7.4, and e cubed is 20. do you see it increases the number? Here, 2 cubed was 8. And e, which is slightly bigger than 2, which is around 2.7 cubed, is 20. So there's a large variation. We're going to now graph y equals 2 to the x, and then we'll write a Python script to graph both y equals 2 to the x and y equals x so that we can look at the difference of the curves. Let us consider the table of values for y equals 2 to the x and the graph as shown. I label x equals 1, 2, 3 and minus 1, 2, 3, and y goes from 0 to plus 8. I don't look at minus y because the exponential functions that we're considering and we're looking at are always greater than 0. And this is x and this is y. So let us first consider what happens when x is greater than 0. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. And when x is 0, y is 1. Let us look at now when x is minus 3, y is 0.125, or somewhere around here. When x is minus 2, y is 0.25, which is a little bit bigger. When x is minus 1, y is 0.5. Drawing the curve, we have something that looks like this. Now notice, if x gets bigger and bigger, we approach 0 but never touch it. As x gets bigger in the negative direction, when x gets bigger in the positive direction, we notice that it grows rapidly. This is called exponential growth. And this part decays to 0 rapidly as x increases in the negative direction rapidly. Okay, now let us look at a cool Python script that illustrates the graphs y equals 2 to the x and y equals e to the x and compares both of them. Let's take a look at that. It's cool stuff. All right, this is our Python program. I brought up a program called PyCharm, which is an IDE known as an integrated development environment. You can use some other Python from Anaconda or Spider that'll also do the same thing. So if you look at the first few set of lines, I import a NumPy, I import a math library, and I import the plotting library of matplotlib. Then I have a function def plot underscore init, and I set a few things. I set the grid to true. I set a y limit of 20 in the top direction, and on the bottom I set -5. Actually, I'll change that to 0 to coincide with what we had earlier in our table. Then I define the x label, just x. Then I set a x variable here, linspace from -3 to 3 and 100. So what is that saying? That's saying that in the x direction, I'm going to go from -3 to +3, and I'm going to have 100 set of points. The constant that we talked about earlier, which is around 2.7128, okay? Then I define my first equation, y1 as 2 to the power of x, y2 is e to the power of x. Then I set a plot figure, and I plot x, y1 in red and x, y2 in blue. I call my initialization function plot init to set up the grid, and I set the y label to be exponential functions for a greater than 1. And I do finally a plot.show. So let's look at what happens when we run it. Look at that. Isn't that beautiful? So the red curve is y1, which is 2 to the power of x, and the blue curve is y2, which is e to the power of x. And you can see when x is 0, y1, for the curve y1 equals 2 to the power of x, you can see that that's just 2. And when x is 1 for the blue curve, which is slightly more than 2, which was the e to the power of 1, right, which is 2.7. And as we go in x, you can see how the blue curve really accelerates upwards or exponentially outpaces the red curve. Let us look if I change the upper bound or the y limit, the top value, to say 100. And rerun it. Okay, and let us change the x. We'll go from maybe minus 10 to plus 10 and rerun it. You see how the curve drastically changes for a small value of x of, let's say, blue curve really takes off when x is. Let us now consider the case when a is less than 1 for y equals 1/2 over x, and take a look at what happens. If we construct a table of values, x, y equals 1/2 to the x, and again we have minus 3, minus 2, minus 1, 0, 1, 2, 3. When x is minus 3, we have 1/2 to the minus 3, or 2 cubed, which is 8. When x is minus 2, we have 1/2 to the power of minus 2, which is 2 squared, which is 4. We have 1/2 minus 1, which is 2. When x is 0, that's 1. When x is 1, we have 1/2, 1, which is 0.5. When x is 2, we have 1, 2 squared, which is 1/4, which is 0.25. And when we have x is 3, we have 1 over 2 cubed, which is 1 over 8, which is 0.125. If we draw this, x, y, and we label some points 1, 2, 3, minus 1, minus 2, minus 3, and we go in the y up to 8, 1, 2, 3, 4, 5, 6, 7, 8. Again, remember, we are drawing y equals 1/2 to the power of x. So when x is minus 3, y is 8. Somewhere here. When x is minus 2, y is 4. Here. When x is minus 1, y is 2. When x is 0, y is 1. When x is 1, y is 0.5. When x is 2, y is 1/4. And when x is 3, y is 0.125. If we continue going in the x direction, increasing 4, 5, 6, the value of y will get smaller and smaller. Let us join the dots here. And make some observations. As x increases negatively, our y increases. And as x increases in the positive direction, our y decreases. Let us look at a Python script that looks at y equals 1/2 x and y equals 1/3 x. So here's our Python script. If we look at the first few lines, again, we're just importing the NumPy, the math, and the matplotlib. We're defining our function. Nothing has changed. This time, again, we're going our y limit, our upper limit, is going to be 100. Our x will go from -10 to 10, linearly spaced with 100 points. And then our y1 will be 1/2 to the power of x. Our y2 will be 1/3 to the power of x. And then if we look, we plot xy1 in red and xy2 in blue. So 1/2 to the power of x will be in red, and 1/3 to the power of x will be in blue. Let's run this and take a look and see what happens. So there you have it. The red curve is 1/2 to the power of x, and the blue curve is 1/3 to the power of x. So let's say for x equals -2.5. And similarly, when x increases from 0 to 2.5 to 5 to 7.5, you can see both curves will tend to 0. So essentially, to recap what we had, to review, if we look at y equals a to the power of x, and when a is 1, it forms this kind of curve here on the left, passing through 0, 1. So as x increases, y increases. And as x gets more negative, it goes down to 0. Now on the other hand, when a is less than 1, the right-hand curve here, we go from y, which is large when x is negative, we cross through 0, 1, and as x increases, we go down to 0. This concludes our lesson. I hope you enjoyed it. Please click like, comment below, and subscribe to my channel so that you can get the latest and greatest news on math. Have a great day. Bye-bye.